We are now looking at another method of determining project durations using Pert method. So this is just another way of determining the critical path using an approach called the Pert, or the project evaluation, let's say, technique. So we want to now get to know what is involved in Pert and how we can now construct that critical path. So Pert works on two theories. When determining the critical path, you have to find the mean duration time. When determining the critical path, you have to find the mean duration time. So usually, like in a network, like from node 1 to node 2, for example, there's usually a certain amount we are putting here, maybe like a 3 or a 4, something like that. Now for Pert, like that number should not just come about there, right? You have to like make some calculation which gives you the mean duration from point 1 to point 2. That's what it's all about, Pert. So in order to now get that mean duration time, there are 3 times that should be looked at for a possible router. There's what they call, let me just write them on the screen. Is what they call the most likely time. There are 3 times most likely time. Is what they call the pessimistic time. I don't know if the spelling is right, but okay, it's pessimistic time. Then now we also look at what they call the optimistic time. So they're just like 3 times which will always be given in a question. From these 3, they will help you determine the mean duration time from moving from a certain particular node to another. Yeah, so all this would make sense when we actually look at an example. So, but just before we go to an example, how will we be getting these same mean duration times? Yes, we have just said, okay, these 3 will be mentioned in a question. Now, how will we be getting those, should I say, values, like for mean duration, okay, and whatnot? So there's a formula that we use to calculate the mean duration time. So what they actually do is this. So mean duration time is actually equal to your optimistic time plus, they just abbreviate with letters, 4m. M stands for most likely time, plus p, pessimistic time, over 6. This is the formula for getting what? Mean duration. Remember, we're looking for the mean duration. Like if you're moving from a certain particular node to another one, want the mean duration given those 3 times which you usually find in a question. So this is how you would get the mean duration time. Then there's also what they call is that under this same Pert evaluation, the project evaluation method, you also at some point need to come and calculate what they call the variance. So the variance has a formula as follows for variance. Variance, if you're asked to calculate that in a question, it's O minus P. Divide this by 6. Okay. Then square. So I said O minus P. If anything, I think I might have even swapped this, but okay. You can actually write it as P minus O, or O minus P, because either way, if you get a negative, when you square, negative disappears. Is that true in math? So O minus P, let's just go with the same one on the screen for variance. I'll just abbreviate as VAR. VAR as the variance. So we want to now get into a certain question and see what I'm talking about. How do we get the mean duration time and determine the critical path from there? Yeah, so let's do that. Suppose you have a question like that. The time estimates in weeks for the activities of a Pert network are given below. There is your table. You have, as I said, you'll be always given these 3 time periods: optimistic time, most likely time, pessimistic time. You'll be given for each particular node connection, like from 1 to 2, they give you 3 time periods. From 2 to they give you certain time periods. So it's like from all those time periods will be getting what they call the mean duration from moving from that particular activity, like from 1 to 2. Okay, there are 3 times, but we just want the mean duration, and that is what we'll be doing for each activity. So we've got like from 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6. Okay, we have to get the mean duration, as we said, because there are 3 time periods which are corresponding to these roots. Let us look at the question. Part A says, draw the project network and identify all the paths through it. Draw the project network and identify the paths through it. So the first thing is you have to construct the network diagram, because it will be from there that will help us now determine that critical path. So first of all, let us draw the project. So my advice would be, pause this video, copy this diagram, then as we move that side, I'll just be like highlighting what you need to do next. So get all the details, the optimistic time, just copy the whole table in short, because when I go there, I'll just now be going to, what's the first part A? We answer it. Part B is now asking us to determine the expected project length. That just simply means determine the critical path, because the critical path determines the project length. Take note of that rule as well. So let us go now and get into the calculations. So we are now trying to construct that project. As I said, draw, of course, the network. So 1 to 2 was the first activity. How do I construct 1 to 2? So you would have your first node, okay, node 1, 1 to 2. So you're moving from 1 to 2, okay. You draw that, that's 1 to 2. What next? 1 to 3, meaning there's another node that's starting from 1 going to 3. We're just constructing right now. Okay, 3. Next, there's a part which said 1, 4. Okay, those commas you're seeing there, that just means like from 1 to that, to a certain number in short. So 1 to 1, 4 just simply means 1 to 4. That's where we are now. So the certain activity should start from 1. Mind you, they should be they should be touching the nodes. Yeah, giving us 4. 4 should be there. They've told us that there's another one from 2 to 5. 2 going to 5. Okay, so 2 going to 5, I can put it there. Then they told us, okay, 3, 5 is as good as saying 3 to 5. How do we construct that one? So if you remember, that criteria we used to use in the first video for CPM1 is that before constructing any network, it's best to use what? A pencil, because there are certain routes, that need to be drawn accurately to avoid making errors. So what I want to do is that I want to just swap. I want 4 to just come below so that it does not obstruct this route going from 3 to 5. So this is what I want to do. Just cancelling out that route 4. I want the route 4 to come below here, because yes, it is coming from 1. I just wanted to reposition it. Okay, then there was that 2 to 5. We said 2 to 5. And then they said 3 to 5, like that. So we're just following the instructions. Then they said 4 to 6. So a long line from 4 all the way to 6. And then 5 to 6. Okay, the network is connected. Just like that. The network is connected. So now these lines should have certain capacity values on them. Like the way we had, okay, from A to what, it's a 3. Now in Pert, it's like before you put those lines, get what they call the mean duration. That's what I was talking about earlier on in this video. How do you get the mean duration? Most of the time what we do for mean duration is that we use that formula which I stated, which is the optimistic time plus 4m. Let me just rewrite it. O plus 4m plus p over 6. This is the formula that will be working for each and every activity to get the time periods that will be sitting on their arcs, or the lines connecting two nodes. Okay, so on the first activity, if you go to your table, I hope by now you must have copied the table. From O, we said O is 4. O was 4 on the table. It's like 4 plus 4m. 4 is multiplying m. What was the m value? M was 1 in the table. So it's like 4 by 1, which is 4. Then P was 10 in the table. So you have something like this: 4 plus 10 divided by 6. That's just for the activity 1 to 2. We're trying to determine the mean duration time for activity 1 to 2. So you have 4 plus 4, which is 8, plus 10, 18. 18 divided by 6, 3. So that will be the time period that you will record where on activities 1 to 2. From moving from 1 to 2, there should be 3 there seated, just like that. Next, we are trying to now create the next activity, which is 1 to 3 according to our table. 1 to 3, the O value is, okay, what I would do is, okay, the O value is 3. It's 6, sorry, 6. Then there's 4 by m. What is m? M is now 4 according to root 1 to 3. Then now we have 8 as p. So the same formula we started with on top, that's the same formula you'll be working with. So you add your 6 plus, what's 4 times 4? That's 16, because there was that 4m, right? And our m was 4. So 16 plus 6 is 16. At the find there was an 8, right, for p. So it's like 16 plus 8, which is 24. 24 divided by 6, 4. We record the root from 1 to 3 should have what figure? 4. Next, we try to determine now the root from 1 to 4. It had O of 8, M was 2, P was 20. If you substitute in the formula, you will get, okay, they'll get, of course, 2 times 4, there is 8, 16, 16 plus 20, 36 divided by 6 gives me 6. So from 1 to 4, you should get a mean duration of 6. Next, from root 2 to 5, they've given us as well 3 different time periods. Let's get the mean duration. There's a 1, and there's another 1, there's a 7. Let's try to compute. It should be 1 plus 4, which is 5. 5 plus 7 is 12. 12 divided by 6 is 2. So from 2 to 5, 2. Next, root 3 to 5. Root 3 to 5 has numbers of 2, 8, and 14. Let's compute the mean duration from root 3 to 5. There you should get, okay, there's a 32. When you multiply the 4 by the 8 there, the m value is 8. 32 plus 2, 34. 34 plus 14 should give us, you should be able to get 50 or 48, sorry, 48. 48 divided by 6 is 8. That's the value which will be from 3 to 5. We are moving. There's another root, 4 to 6. 4 to 6 there, we have 3, 10, and 11. So 10, the 10 is on the m value, so 10 by 4, 40. 40 plus 3, 43. 43 plus 11, 54. 54 divided by 6, 9. So 4 to 6, they should be 9. 5 to 6, the last number, we have a 2 on O, a 6 in M, and a 16 in P. So the 6 which is in M, 6 by 4, 24. 24 plus the O, which was 2, which is 26. 26 plus 16 should give us 42. 42 divided by 6, 7. So from 5 to 6, the mean duration time should just be 7. You have put the values, and from here, I'm sure it should now be easy to now determine the critical path, because you now have values, and to determine a critical path, you usually use what? The values that are along those nodes. So the question part B was like, now determine the project length. I earlier stated that simply means is that that's just telling you to create the critical path. So you have to just determine the critical path from this data given. Maybe let's use my shortcut method, since CPM2, if you watch CPM2 video, it has touched on that method, which you create a small box like right here and the heart like structure, right? Okay, that's as per standard, but I want to just use another alternative to create the critical path, because it will still give you the same answer at the end of the day. So what I'm going to do is that, okay, let's look at the possible routes which are here, right? Leading to 6. We're going to 6. That's our end game. We're reaching 6. So there's a route from 1, 2, 5, and 6, right? What are the figures along that route? 3, 2, and 7. Total, we should get a 12. Okay, you even record some. Okay, 12. This one's giving me a 12. Okay. Next, we're going to 6. You can use route 1 to 3, 3 to 5, 5 to 6. Answer, There's 12 plus 7, which is 19. Okay, possible root 19. Next, 1 to 4, 4 to 6. Answer there, 15. Okay, so we put 15 there. I'm sure our critical root is the one having the largest outcome. As we said, critical root is always the longest root in a network. Just remember this. The critical root or path is always the longest root in any given network. So it's definitely that one from 1 to 3, 3 to 5, 5 to 6. Okay, and sorry for that. I've just realized that, okay, from 1 to 3, there's supposed to be a 5. I think it was a computation error. Yeah, supposed to be a 5 there. Sorry for that. So it's supposed to be like from 1 to 3, there's supposed to be a 5. Then from 3 to 5, 3 to 8, 3 to 5, there's an 8. From 5 to 6 is 7. Of course, the total root should have been 20 now. Yes, I just had the wrong figure put out there. So you will have like your figures there, 12, 20, and 15. Then we said the critical path is one having the longest amount of days, which is 20. And that's the route from 1 to 5, 1 to 3, 3 to 5, 5 to 6. Yeah, so just say, of course, therefore, I'm just trying to squeeze in my answer for the critical root. I'll just put it right next to node 4, which is 1, 2, 3, to 5, to 6 is the root. Okay, that's your critical root. You even highlight it in the question or in your exam or solution. And then you put, okay, this root was equal to 20. Then you have answered part A and part B, just like that. So there are now certain things they might ask you to now, like, you're trying to compute probabilities. They might ask you that, what is the probability that this project will take 22 weeks? For example, what's the probability that this project will take 22 weeks? What would you do in that scenario? So what you're just required to do is that we come to apply some knowledge from statistics, specifically knowledge under normal distribution. So I'll just illustrate that same example I've just given. You have done, okay, part A, part B. So they just ask you another question. What is the probability that, okay, this project can take 22 days? But here it has just determined you that, okay, the maximum I should take is 20 from our critical path determination, right? Yeah, and before I even erase this, I want you to just always be identifying the critical path by dotted lines, like you mark it so that the examiner knows that, okay, this person has determined it even diagrammatically. Now let me just try to erase this and go to that part which I was about to mention, where you might be asked to compute what's the probability. How would you do that? So let me just erase whatever is on this screen so that I can have enough room now to show you how you work around that detail. Okay, so as we said, we are applying the rule from the normal distribution. Normal distribution states that, okay, when you're calculating probability value, we use what they call Z tables. Yeah, okay, I don't really know what the Z stands for, but mostly they just call them Z tables. Yeah, so these tables highlight a certain formula on how you can be getting probability by computing the value for Z. Because once you get the value for Z, you'll go to this same Z table and get the value that will be along that Z value that you find in your formula. So the formula that we use, first of all, is Z is equal to X minus, they call this mu, over the standard deviation, that symbol there below, standard deviation. So this is the formula we need to come and work with to get probabilities. So how will we like in our question to get these certain values that will be able to help us substitute in this equation? What you just do is that you need the mean. This stands for mean. This U stands for mean. What is mean? Mean is basically what we've been doing throughout the Pert's evaluation. Those values we are getting as the mean duration, they qualify for mean. So what you're going to do is that you list the mean for all the activities given from 1 to 2, you put the mean duration. From 1 to 3, you put the mean duration, and I'll be showing you very soon how this needs to be answered. After you've done all your mean values for all the possible routes, get the the variance, because if you remember from the intro, we told you that in this topic you will need to be told, okay, how to calculate, of course, the mean, durations, and the variance. Okay, so the variance as well is that formula for, we said variance is actually supposed to be equal to O minus P divided by 6, close brackets, squared. So you also have to like get the variance values for each root. From 1 to 2 you get the variance, from 1 to 3 you get the variance, and then you have two columns, one for mean, one for variance. Then get their totals. Basically that's what we do. Once you get their totals, if you remember the z function, right? The z function, I'll rewrite it again, which is helping us to determine probability, is equal to x minus mean. That same column I'll even show you what I mean by getting the total of the mean. That total of the mean value, you come and substitute it here. Divide that by what? You divide that by the standard deviation. Okay, so you divide that by the standard deviation. So standard deviation, you might wonder, okay, but we only have the mean column and the variance column. How do we get standard deviation? Standard deviation just simply means squaring the what? The variance. So that would be very simple. You already just have the total for variance, just square that total and it becomes the standard deviation, and you can easily substitute in this should I say table. So I'm just going to quickly show you what I mean by now when you've been asked, okay, how do you find the probability maybe in 22 weeks, given that, okay, you've got this project. So you might be, like I said, well, okay, what's the probability if the project took 22 weeks? So first of what I've just shown you here is the calculations that would have been taken. The critical path there, 1 to 3 to 5 to 6, right? That's your critical path. Then of course we said we compute the values that were along that path to get the total amount of days, because they said what is the project length, which gave us 20 weeks as determination from the critical path. Then they ask you, okay, what if it took 22 weeks? What's the probability that this project will be completed in 22 weeks? First of all, what you do is that, as I said, you need a column for the mean values, because remember the z function, if you rewind the video, the z-score value, it's always x minus mean divided by standard deviation. Mean, we said we need the column for mean, as I said. Then the Pert method only gives us on how to calculate variance. So we will need variance because it's a key component to get that standard deviation that is in the z function equation. So we'll get these two columns just like that. Now one might ask, how come my table looks smaller than the original question? Well, what I've done is that when you're making this table, you're now focusing on only those activities that were along the critical path. Now those are now excluded, those other routes. When you're determining, maybe they tell you what's the probability of getting the project getting done in 22 weeks or in 14 days, you only look at the, should I say, the routes along the critical path, which is 1 to 3, 3 to 5, and 5 to 6. That's all. That's our focus. And then, as I said, you get the mean values for each of those routes, like we've been calculating mean throughout, mean duration. If you rewind, you find the formula. Then you get the variance. Variance, we have also put the formula in this same video. You just rewind, you find the formula for variance. It's optimistic time minus pessimistic divided by 6. Then you square the answer. That's your variance for that particular route, which gives you values like that, as you can see. 9.55. You sum up, as I said, you sum up the two columns. The mean, of course, is 20. Okay. Then you can get the standard deviation from variance, because it's just square root of the variance, which gives you 3.09. From there, you can now easily go and substitute in the z function. So let me go back to my screen there and show you how you now be substituting in the z function. So we're now trying to get the probability, and probability is equal to this. Okay, x, that over mean standard deviation. What is x? X is like what they tell you. Okay, suppose it's 22, suppose it's 14. That's what goes on x. So just put, okay, 22 is what they're asking for, minus the mean 20 over standard deviation 3.09. The answer for z is equal to 0.65. I think it was a recurring, but we just round off to 2 decimals. What next? Go to the table, the z table. You should have that table, and locate where there is z 0.65. So maybe for those that might be doubting on how do you even interpret that same z table, it looks like this. There will be some values that will be along the z, then there will be some values that will be there. So you'll be finding like there will be, for example, let's say 3.9 somewhere there, 3.8, like okay, numbers decreasing, something like that. What would be along this horizontal line? You maybe find okay, point maybe like 0.01, 0.02. So what that just simply means that okay, when you reach 3.9, for example, like the z-score came out as 3.9, then you know, okay, maybe your z-score came out as 3.92, for example, right? How do I get that on a z table looking like this when I can only see 3.9? How do I get 3.92? So what happens is that you first locate yourself to the 3.9 first, like 3.9. This is just an example. We'll get back to our question very soon. This is like 3.9. You get there. How do I get 3.9? 3.92. Well, those values are along that horizontal line where there's 0.01, 0.02. They like add on to this value that you get along the z line. So you're looking for 3.92. Just go and go to the point where there's an ending of 2, because you're looking for 3.92, which will lead you to this part here. Because if you add 3.9 plus that, what does it give you? 3.92. And you've located that exact position where there's a probability for the z function of 3.92. That part where I've circled, there will be always a certain value there. Basically, that's how they've highlighted the z table. They always put only to one decimal. Then if you're looking for more decimals, like we rounded off to 2 decimals, you would always have to extend it by those values that are along that horizontal line. If you're looking maybe for, okay, 3.92, okay, you look up there, is there anything which is ending with 2? That's the one which you end on, and you link 3.9 to that ending, and you get the value that's usually there. That's how we get our answers most of the time along the Z table. So we had, in our example, we had, okay, the Z, we are computing it. We got, I think, 3 point what? We got 0.65. How would we also get this figure? There will be a point in the Z column that will have 0.6. I'm just like rushing the table, okay, like, okay, dots, okay, until maybe 0.6. We are trying to get 0.65. Most likely you would have found it again as well. We said, okay, it only gives the first decimal. Then you look along this horizontal line. If you find this ending, okay, like, oh, there's an ending of 0.05. If I add 0.6 plus that, I'll get 0.65. Meaning the probability value that I'm looking for falls in the line of that 0.05 and the 0.6. That figure there is the one. The answer is that just the figure you find there is the one. Yeah. So basically that's how we're going to get that answer. And you find that, okay, as of our example, you should find the z-score of 0.74 something. I'm just rounding off somewhere there. So if they ask you, oh, what's the probability? The probability is just equal to 74%, because that's the z value that you found at that point. And then you've answered. So basically, this is the Pert method of how you can determine the critical path. It's another theory. And then thereafter, you might be given, okay, what's the probability if it took these days? We just apply normal distribution. So knowledge from statistics comes back. We need to be well acquainted. So that's why I had to spend time on explaining on that Z table, just to act as a refresher from, the statistics topic in normal distribution. I've noticed in the Pert video and the CPM videos that, of course, when we're drawing those nodes, like node 1 going to node 2, we have not been including arrows. Well, it's a requirement in this networking process that when you're drawing a network from one node to another, arrows should be inclusive like that. We just did not include them. It was just for quick calculations and the like, but please, arrows have to be included to show direction of where an event is going, and from that point to another. Just take note of this whenever you're drawing any networking model.